Problem 22 has to do with similar right triangles, which is a big topic from geometry. So you should know something about this, especially this type of triangle where you have a right triangle and then you draw an altitude from one vertex to the hypotenuse. So that would be the segment DB in the picture there. And an altitude, again, is a line that is perpendicular, starts at a vertex and goes perpendicular to the opposite side. When you do that with a right triangle, you will get three similar triangles from it. And I usually like to say there's one smaller, one medium size, and one large. So the smaller one is going to be, in this picture, is ADB. And we're told that CD is 9 and AD is 3. Then the second, or the medium sized triangle, would be BDC. And again, we're told that CD is 9. And finally, the large triangle is the big outside triangle, which we would call ABC. And we know that AC is equal to 12. Well, when you line up these triangles in this way, we know that side AD is side AD, and AD to BD is in the same proportion as BD to CD. So the missing side, BD, we can call X. And so X would be called the mean proportional in this particular case because the denominator of one is the same as the numerator of the other in a proportional. That's called a mean proportional. But we still solve it the same way. We cross multiply. We get x squared is equal to 27. And x would be equal to 3 times the square root of 3. Now if we wanted to, we could calculate side AB because we will need it. We're looking for three things. We're looking for BC plus AB plus BD. So we would use the Pythagorean theorem to calculate side AB. And it would be the square root of 3 squared, which is 9, plus 3 square root of 3 quantity squared, which is going to be 27. 9 plus 27 is 36, and the square root of 36 is just 6. So segment AB is 6, and that's one of the things that we're looking for. And we can write it in over here as well. So now the only thing that we're looking for, we do know BD as well. That is 3 root 3. So the only piece that we're looking for now is segment BC. And segment BC we can find either of two ways. We can calculate it as the hypotenuse of the middle triangle, and so that would be square root of 3 root 3 squared, which we saw already is 27, plus 9 squared, which is 81, and that would come out to be the square root of 108. We can write that into the other triangle as well. And breaking that down, that's 3 times 36, square root of 3 times 36, which turns out to be 6 root 3. And so we have the final piece. So altogether we have 9 root 3 plus 6, which is answer A. And there are some variations in the way this could have been solved, but this is one way of setting up and solving this particular problem.